Hi, you're welcome to Asanji Academy for Global Conquest, and we will be looking at experimental and graphical physics. I think this is a very important chapter in physics. Experimental and graphical physics is a very important chapter that I would like you not to miss any iota of time in following up what we are discussing today. Once more, you are welcome. Uh, it is the fourth lesson in our study, and we will be looking at, as I've said, is experimental physics. So I want to load the content so we can look at what we'll be dealing with. Now, an experiment is a scientific process that is carried out to study or to investigate a phenomenon in order to know how it occurs or to know or to gain new knowledge about that phenomenon. An experiment is we are carrying out, we are making a study, an investigation, a research about a phenomenon. It could be about the dispersion of light. It could be about the specific heat capacity of a liquid. Experimental physics is a science of carrying out a test or experiment on a physical quantity for a given purpose. Experimental physics is therefore the science of carrying out a test or experiment on a physical quantity for a given purpose. So it could be you're trying to carry out a test on a physical quantity. Yeah, as we have said, it could even be the focal length of a convex lens. It could be the specific heat capacity of a solid block. Now, let us look at the reason for experimentation. Before we get into that reason, I would like us to also see that there are two types of experiments. We have the standard experiment and we also have a real life experiment. For a standard experiment, the time of the experiment can be determined. For example, you want to measure the acceleration of free fall. You can say that this experiment is going to run for 2 hours. You can say that this experiment has to run for 1 hour or 1 hour 30 minutes. Now, going back to a real life experiment, the time of the experiment depends on it depends on the nature of the experiment. The time depends also on the nature of the experiment. For example, it could be investigating the rate of evaporation of water. You see that by its nature, it has other factors that determine that rate of evaporation of water. Maybe the dryness of the atmosphere, maybe the weather is the wet day or a dry day. It could even be what about the surface area of the water exposed to the atmosphere? Is there wind blowing? You see, those factors will determine on one day the experiment could run for a certain duration of time, and for some other day it might not respect it because those factors vary. Now, understanding that there are two types of experiment, a standard experiment and a real life experiment, we now look at the reason for which experiments are carried out. One, to verify a well-known law. It could be the law of conservation of linear momentum. It could even be the law of conservation of energy. It could as well be Newton's laws of motion. What other reasons do we carry out the experiment? Why do we carry out experiment? To measure and to determine the value of a physical constant. To measure or determine the value of a physical constant. It could be we want to determine the value of the acceleration of free fall by measuring the distance and the time a body will fall through is that distance. It could also be that we want to design or we want to construct a system or a device that can be used for a particular purpose. Uh, Let me give this example. You could choose to construct a ripple tank. You could choose to construct a ripple tank such that you can use it to study waves. You could also choose to turn a tangic container or a supermount container into a measuring cylinder, and so you want to cut it and do graduations so that the tangic container becomes a measuring cylinder. So these are some of the reasons for which experiments are carried out. It can also be to make an open-end investigation in which the outcome is not known. and cannot be predicted. In this case, you choose the equipment and design the experiment by yourself. The experimental procedure. Okay, in physics, an experiment rules according to steps. These are the steps that you report experiment, the steps that experiments are carried out, that we follow when we carry out the experiment. Step number one, we have the aim of the experiment. We have the experimental setup, which includes a diagram. We have the procedure. We have observation, which include data collection and sometimes graphs. If graphs are necessary, we plot them. We have the calculation or the analysis, we have the precaution, and finally the conclusion. So these are the steps: aim of the experiment, the setup, the procedure, the observation or data collection, we have the calculation and the analysis, we have the precaution, and the conclusion. Let us look at these steps one after the other. The aim of the experiment. What is the aim of the experiment? It is what is aim? It is the purpose of the experiment and it must be clearly written out. The aim of the experiment, the purpose for carrying out this experiment. Why am I carrying out this experiment? To determine the focal length of a converging lens. That's the purpose. It must be clearly carried out. To measure the speed of sound in air. That is the aim of the experiment. The setup. It involves the apparatus needed and the design system in diagram format that will be needed to carry out the experiment. Under setup, we make sure that the diagram and the apparatus from the diagram, when the diagram is drawn and labeled, you see all the apparatus that are needed, and even from the diagram you can start figuring out what the scientist or the experimenter is about to do. Set up the procedure is also very important. It is the actual measurement of the magnitude of the physical quantities involved using the appropriate instrument. In this stage, we are measuring. For example, we want to determine the speed of sound in air. We already know that for speed to be determined by direct measurement, we need to measure distance, we need to measure the time. It is under procedure that you will tell that we see how distance is measured and how time is also measured. In this stage, at this state requires that the physical quantities to be measured should be spelled out, stating how they are measured with the correct instrument. Still on the case of the speed of sound in air, what are we measuring? We are measuring distance. What are we using to measure distance? A tape. And what's the unit of measurement? It's certainly going to be the meter. What else are we measuring? We are measuring time. What are we going to use to measure time? We use a stopwatch and the unit we measure in second. So under procedure, you should actually spell out the physical quantity that are being measured, the appropriate instruments that are being used to measure the physical quantity, and also the units of measurement. Lastly, this state shows how the quantity is varied as you get the corresponding value of the order. You show how the quantities are varying as you get the corresponding. It is on that procedure that you indicate, for example, Ohm's law. Maybe when you vary the current, this is how you get, this is what happens. The PG also varies or it remains the same. When the current varies, maybe the PD or the PD varies or it remains the same. So because we are going to measure current and PG. So you tell it is under procedure that you indicate that we vary the current in order to get a corresponding variation in the corresponding voltage variation. Observation and data collection. This is the presentation of the data collected from the experimental setup or measurements made during the experiment as the quantities vary. The data is usually displayed on a table with columns titled with the physical quantity and corresponding units. What does this mean? It means that whatever is observed, remember, observation is not only what you see, like a color change, yeah, or increase in the volume or size of a quantity. When you are collecting data, the data that you collect falls under observation. This data should be displayed on a table format with titles. It could be you could be working with the acceleration of free fall. Therefore, you will have length and period. You now have values of length and corresponding values of period. Lastly, it should be noted that for better results, at least 8 pairs of readings should be taken over a wide range possible, with each reading repeated at least twice and an average value recorded, which means if you are dealing with the acceleration of free fall, or you want to measure the acceleration of free fall using the pendulum method, it means if you take 20 oscillations and the time is maybe 30 seconds, you have to take the 20 oscillations again. If the time is 32 seconds, you now add 30 plus 32 divided by 2 to have an average value. If you now change the height, if you reduce the length of the pendulum and you take it for 20 oscillations and the time reduces to 20 seconds, you have to repeat it again and carry it out for 20 oscillations within that same length, and maybe you will now have 18 or 19 seconds, and you look for an average value. By so doing, you reduce errors in measurement. After that, you now display your information on a graph. A graph is a plot to show the variation of one quantity against another. A graph is a plot on an XY plane which shows a variation of one physical quantity against another. From the graph, what will we get from the graph? We can approximate from the graph, approximations and predictions can be made. The average value of a constant can be determined from the graph as well. Why we can make approximations from the graph and we can also make predictions from the graph. A good graph should have axis labeled with units. It should have a good scale. It should have a title. It should have a neat line or a curve. Make sure the line is not printed, the curve is not printed. It should be drawn once to pass through most of the points. If not, it should mediate the points. It means if there are some points that are left out, the number of points left above the graph, above the line, should be equal to the number of points left below the graph. Now, you don't be scared. We will actually do graphing and all of these things will be explained. I will explain. We will see how to choose a good scale, how to draw a neat line, how to label the axis, and how to label the axis with units. So we will see how we can do approximations with graphs, how we can do predictions with graphs, how we calculate constants with graphs. So just this sketchy is so sketchy, but we are going to do practically, we're going to draw a graph. Now we get to the calculation and the analysis. This is the process whereby the data and observations are used to arrive at a conclusion. This can be done by using existing formulas or by deriving new ones. As I've said, we're going to take a practical example so you'll see how calculations can be done. For example, if you want to measure the speed of sound in air, after your data is displayed on the table, after you have the data collected, you will now plunge it into the equation, depending on which of the methods you use. Was it the reciprocal firing method? Was it the echo method? They have their equations. Now you substitute the parameters into the equations and you will have an answer. Precaution. Wow, this one is very good. What is a precaution? This involves what is done within the experimental procedure to ensure accurate result, or what has been done to minimize errors. When you are measuring the specific heat capacity of a liquid, for example, water, we know is a poor conductor of heat, a poor thermal conductor. So one of the precautions is to stir the water for uniform distribution of heat. We stir the water for uniform distribution of heat. That's a precaution. That is what you do in order to ensure accurate results. When you are working with the Ohm's law, sometimes we are told that the material under investigation can be dipped in oil so as to soak out heat from the conductor, because if it is overheated, it's going to affect our result. Still, in when we are working with when you want to determine the specific heat capacity of a solid block, sometimes you are advised to pour glycerin in the holes so as to ensure good thermal contact between the conductor, the, between the solid block and the thermometer. You pour glycerin in the hole that contains the thermometer for proper thermal contact. That is a precaution to ensure accurate results. Conclusion. This is the final answer or decision taken. Maybe you were calculating the acceleration due to gravity. Your conclusion could be the final answer that you got. Maybe it's 9.82, 9.80, 9.81 meters per second square. That is your final conclusion, the final answer or the decision that you arrived at. Well, we have come to the end of this lesson. I want to believe you got something from it. I will encourage you to like and share, subscribe, like and share so that our page could remain running. Thank you and see you in our next class.